Hi, this is Robert Greer. This is Sprint 3 for CSC 588. I'll start with the handle system. So I have a handle class with an ID and index. In its constructor, it activates itself, and then in the destructor, it invalidates itself. So that's the basic idea of the handle. What this means is in the handle manager, you can activate and validate handles. It's a singleton with the table of IDs, and it's protected by a mutex, so it's thread safe. So in the public methods of the manager, I lock and then unlock the mutex to protect it. And the functions manage the various registrations of the handles for the sounds. So that's the handle system. Next, for the circular queue. So here's the circular queue. You can push and pop these command pointers, which are just basic commands. And then it has a mutex to protect those functions. So it uses the front and back circular indexes to be a circular queue, and then it's protected by the mutex in both of these functions. So that's the queue there, and this is used by the audio thread. So when I start the audio system, I create a new thread on audio thread main, and that gets launched, and then when I destroy the audio system, I join that thread back up to main. So the thread looks like this. Here's main. So it creates its own managers, and then it destroys its managers at the end, and then it has this main loop where it just pops commands off the queue while it can, and then it will execute those commands, and that's basically all it does for now. And so these commands can do various things like creating a sound, ending a sound, loading an asset, changing a sound, that sort of thing, and it allows me to program that audio thread. So that is the thread communicating with the circular queue. Next, for how this is all used with the sound system. So I'll start with the game sound. So this is the game thread's handle to the sounds on the audio thread. So the game thread owns one of these. It's got a handle and an ID. And basically, all you can do is start the sound and then mutate it. And both of those functions are protected by the status check on the handle. So you can only do the things if it's a valid handle, and you can do, set the properties, start, stop, restart it, whatever, all using the handle. And all that will do is call to the game sound manager to push a command. So for example, when you play the sound, it pushes a create sound command onto the queue, and then that will be read by that audio thread. So all the actual work is being done on the audio thread when it comes to that kind of work. So what happens is when you pass in one of these commands, you have on the other side, in the audio thread, you have an audio asset manager. So this has a list of audio assets. An audio asset just has a buffer and file info. So that just represents a audio file, and then those could be used to spawn sounds. So you have a sound, it's constructed from an audio asset, and it's associated with a user handle. And then these sounds actually have the sound source and the buffer, and the callback. So these are managed by the sound call manager, where you can basically add new sound calls and remove them and mutate them. So that's basically what happens is you put commands on the queue, and then the commands interact with the sound call manager to do stuff. And so, for example, when you create a sound, grabs the asset, creates the sound, puts it on the manager. So let me go ahead and start demoing all that. So I have this demo set up to do all that. So when I start in load content, I have various loading assets. So I associate an ID with a file, and you can see that here. I build up that list of audio assets. And then in the demo itself, when I start it, it's creating a new sound. It's not playing, but I set up a handle. So I have this new handle here in my handle manager, and then I can start the sound. I can pause. I can restart and pause again. So all that is sending commands over to the audio thread to to call those functions on the actual sound class. And then I can do other things with the properties. So the volume, for example, up, and then volume down. And then I can pan it. So pan to the left, and pan over to the right. And then I can set the pitch as well. So I can pitch down and pitch up. Okay. So, yeah, so that's the properties on the sound there. And then I can also spawn other sounds adjacent to it. So like that over on the left, and then this over on the right. And you can see as I spawn sounds, it builds up the active sound call list here. And that's basically how it works. So I'll quit out of the demo. And yeah, so lastly, I'll show some edge cases. So for example, overloading the queue. So here I just send a bunch of commands to the queue, and it's going to overflow and yell at me because I sent it too many commands. So I'll start that. So you can see it failed. I tried to push and the queue was full. So that's what happens when it overflows. And then another edge case, when the handle gets destroyed. Nope. Okay, I screwed up. Anyways, so another edge case, when you invalidate a handle and then you try to set one of its properties, it'll yell at me as well because I'm asserting that it has to succeed. So let me destroy the sound. So the sound has been invalidated and there's no active calls. Now if I try to set the volume on that handle, I get an error because the handle's invalid, so the status was not a success. So that's sort of the handle system in action. All right, that's my demo for this week. Thank you.